Good morning. So, in today's video lecture, we are going to discuss about cognitive spectrum management. In this cognitive spectrum management, we are going to discuss about types of spectrum and the spectrum sensing. In that spectrum sensing, we are going to discuss about advantage as well as disadvantage. First, what is meant by spectrum sensing? A key requirement for cognitive radio is spectrum sensing. That is, detecting the presence of other users. Sensing means it will sense whether the spectrum is going to be free or not. So it's going to detect the presence of other user. Other user means here the spectrum is going to be used or unused. It is going to be an active or inactive. So for that here we are going for first one, spectrum sensing. A key requirement for cognitive radio is spectrum sensing, that is detecting the presence of other users. Second, the spectrum sensing is important in a hierarchy CR, that is hierarchy cognitive radio, where the secondary devices are obligated to avoid interference to primary user. So hierarchy means here we are going for primary user and then secondary user. In no way the secondary user, it should not disturb the primary user. So in this way the hierarchy has been formed. So they are going to be follow the protocol. What was the protocol means? It should not disturb the primary user. Who? Secondary user, it should not disturb the primary user. Spectrum sensing gives information for spectrum sharing also. Why? Because means it will sense whether the spectrum is going to be used by other user or not. It is going to be free or not. It is going to be active or inactive. So that with this information, the spectrum, the identified spectrum, it can able to share to the different user. So the spectrum sensing gives information for spectrum sharing also. Last, interference at a specific receiver is often categorized by the interference temperature, which describes the interfering power spectral density divided by Boltzmann constant Kb. So interference at a specific receiver is often categorized by a interference temperature. So with this temperature they can able to find out, which describes power spectral density with the help of a Boltzmann constant. Here we are going to discuss about four kind of condition. With this you are supposed to find out the we are going to discuss about four problem. According to the four problem, here we are going to find the solution. First, solution number one. Key problem is one can sense only transmitted radiation. A complete passive receiver invisible to any sensor. This important dilemma has not been solved. So here the problem is one can sense only transmitted radiation. A complete passive receiver is invisible to any sensor. So this important dilemma has not been solved. Now we are going to find out the solution for given problem. Assume a transceiver. Transceiver means both transmitter plus receiver act as a primary devices. From transmitted radiation, the presence and locations of the primary devices is reduced. So with the transmission radiation, the presence and the location of the primary device is reduced. Knowledge on duplexing policy. Here how they are going to acquire the knowledge is with the help of a policy called duplexing. For example, a frequency division duplexing primary transmit in a particular band. A secondary system could know in which band such a primary system device could receive. Obviously, the knowledge should be known by the duplexing to whom you are going to have the access. What was the current scenario? Even though you are going for primary and secondary, the primary transmitting signal in a particular time, the secondary system could know about the primary device to whom it would receive. That is nothing but knowledge on duplicity policy. Next, solution 2. That is problem number 2. Observe the spurious emission of the primary receiver. Here we are going to observe spurious emission of the primary receiver. For example, the vocal oscillator of a TV receiver are not perfectly isolated from the antenna, and thus their emission can be observed by the secondary system. So here, even though we are going to use the local oscillator in your TV receiver, which is not going to be perfectly isolated from the antenna, these they can able to observed by the secondary system. So that was the solution. For example, the local oscillator of a TV receiver are not perfectly isolated from the antenna, and thus their emission can observed by the secondary system. Drawback. The observed signal cannot easily be mapped to the local of the receiver. That is, local means location of the receiver. Even though you are going to observe the signal, but it's not easy to map to the location of the receiver. It discourages good receiver design. That is, the design that do not have significant spurious emission. That was the thing. It discourages good receiver design. Next, problem number 3. Assume that the primary receiver are in all possible locations where the primary transmission can be sheared at a level sufficient for demodulation. The question is, assume the primary receiver are all in possible location where the primary transmission can be sheared at the level sufficient for demodulation. This policy is extremely conservative. Receiver that need to be protected are assumed to be within the coverage region of the primary system. That was the policy. What was the policy? Receiver need to be protected or assumed within the coverage region of the primary system. Fourth problem. Let the secondary device start to transmit in any band on the monitor whether the radiation of the primary system changes. Problem is, let the secondary device start to transmit in any band and monitor whether the radiation of the primary system changes. For example, an increase in the transmit power of a primary code division multiple access, that is CDMA, code division multiple access transmitter, could indicate that the secondary device is interfering with the primary receiver. The primary system increase the transmit power in order to keep the signal to noise ratio constant. That is SINR, signal interference noise ratio to be constant. What are the drawbacks? It interferes with the primary user. Obviously, it will interfere with the primary user. Why? Because means here, even though we are going to use CDMA, we are going for interference as well as signal to noise ratio. Challenge in the primary transmitter characteristics due to secondary interference and due to environment cannot be differentiated. What was challenge means primary transmit characteristics due to secondary interference and due to environment cannot be differentiated. Third, it does not work in the system that do not change the transmitter characteristics according to the network. First, it should not work. Even though it's going to happen, the transmitter characteristics will not change according to the network. This is the drawback. Next, fifth, common control channel that allows dissemination of information about the spectrum sensing. Common control channels that allow dissemination of information about the spectrum sensing. These scheme allows highly efficient utilization of the spectrum, but has the drawback that existing device need to be modified to allow signaling on this channel. So this scheme allows highly sufficient, highly efficient utilization of the spectrum, but has the drawback that existing device need to be modified to allow the signaling on this channel. Solution: a database that makes geographic location of primary receiver available to secondary. So these are the six solutions we have to discuss with spectrum. Now we are going for detector. The detector are used for sensing depending upon the amount of prior knowledge that a sensor has about transmitted wave. The detector means it will detect, it will sense, and also it will know the amount of prior knowledge that the sensor has about the transmitted wave. So that was the purpose why we are going for detector. Here we are going for three types. One is energy detection, matched filter, detection of cyclostationary. First, energy detection. It is used when the sensor has no information about the signal structure. So energy detection is used when the sensor has no information about the signal structure. Matched filter. It will provide better performance but can only be used when the transmitting signal is known. It is going to be a better performance, but it should know the transmitting signal wave. Next, detection of cyclostationary. So this detection of cyclostationary property is a compromise solution that does not require knowledge of the waveform and gives a performance that is somewhat better than that of an energy detection. So detection of cyclostationary property is a compromise solution that does not require knowledge about the waveform. Other than that, it will give the performance which is better than the energy detection. Energy detection means what? It will sense when sensor has no information about the signal structure. That is energy detection. It must be noted that a fully coordinated radio requires a matched filter detection. Matched filter detection means it will give the performance, but it should know about the transmission rate. Right. Next, the energy detection. The no knowledge of transmitted wave. The sensor measure energy present in the frequency band. First, sensor measure when user present. Sensor measure when no user. So when user is going to be present or when user is going to be absent, it is going to be depend upon the thermal noise, that is temperature. Detection of whether a signal is present or not is thus a classical detection problem that can be formulated as an hypothesis whether the signal is going to be present or not. But the classical detection problem that can be formulated in terms of a hypothesis testing. So H of naught and then H of 1 are two hypotheses between which the sensor needs to detect, which is gives a low end to high end. So I H naught to H1. These are the two hypotheses between which the sensor needs to detect. By adjusting the threshold trade-off between the false alarm probability and missed detection probability can be calculated. We can able to adjust the threshold trade-off and then probability of false alarm as well as missing detection probability that can be carried out. In a hierarchy congruent radio, the missed detection probability will usually be prescribed by the frequency regulator. Because of a misdirection of a spectrum sense implies that the secondary system will transmit even though a primary user is active in the considered band. That was in hierarchy. The misdirection probability will be usually prescribed by the frequency regulator. The misdirection of the spectrum sensor implies the secondary system will transmit even when the primary user is going to be active in the considered limits. How many sensing value n should be obtained before the decision? So case 1, when n is going to be small, the decision variable has a large variance. Case number 2, n is going to be too large, the decision process takes too much time in order to reducing the spectrum usage and increasing the chance of primary system starts to crash. So these are the two cases. N is going to be small, n is going to be large. N is going to be small means it will take the decision large. N is going to be large, it will take the decision. Matching filter. So you know about the matching filter. It will know the bit, but the primary user will know about the bit. So in this case, the sensor know about the transmitted wave. If the transmitted wave know, then the matched filtering is the best way to improve the signal to noise ratio for detection of. For a spectrum sensing cognitive radio, the output of the matched filter is used as a test statistic to detect whether the signal energy is present in the considered band or not. That was the second band. For a spectrum sensing cognitive radio, the output of matched filter is used as a test statistic to detect whether the energy signal energy is present in the considered band or not. A fully cognitive radio might have to demodulate or detect the symbol transmitted by the primary user. That was the performance of fully cognitive radio. It may have to demodulate or it should detect the symbol transmitted by the primary user. In some circumstances, a sensor might want to detect or decode only the pilot beacons, since those have usually better signal to noise ratio than the actual payload data and might also constant information about the spectrum usage that can exploit by a secondary system. Next, cyclostic and wavelet detection. Moderated signal usually have cyclostic statistics, that is, certain statistical property or periodic. These facts can be employed to enhance the performance of an energy detector. In other words, incoming signal is correlated with itself before being sent to an energy detector. According to the fact, either it can be employed to enhance the performance of an energy detector, or in other words, the incoming signal is going to be correlated itself before sending to an energy detector. Wavelet detection, if the power spectral density of the signal that is to be detected in smooth within a frequency band but shows deep decay at an edge, and wavelet transform can expose the wedge of PN power. So the wavelet is going to purely depend upon the power density, where means it's going to depend purely upon the edges of your wavelet band. The drawback of this technique are highly computational cost. So that's why it's going to be a considered drawback. Why? Because it's computation based on next, multi-node detection. In many cases, the secondary system consists of a multi-node, which then have possibility of helping each other to reach the better sensing region. So if you are going to have multiple node directions, it is going to be a easier one in order to help, and then we can able to reach the better sensing direction. However, each of the secondary node listens and makes an independent decision whether the channel is occupied. The node then exchange this binary information and come to a joint decision as to whether the spectrum is available or not. The nodes is going to be exchange the binary information, and they are going to come up with the joint decision. Depends upon the spectrum is going to be available or not. Even if one node sense occupation, the secondary system decides the channel is occupied. Even one node is occupied, and the secondary system is going to detect the channel is going to be occupied. That is multi-node. Spectrum sensing is going to be a non-cooperative, cooperative, and then interference based. In spectrum sensing, here we are going for narrow band as well as wide band. So three types: non-cooperative, cooperative. So non-cooperative, it is going to be called as a transmitter detection. So each coordinate radio has the ability to detect the presence and absence of the primary emission. So that you know. So according to that method of non-cognitive sensing technique, the energy detector based sensing, waveform based sensing, cyclostationary based sensing, matched sensing, and then eigenvalue based. So these are all already we are discussing previously. Advantage: simple system. Disadvantage is to suffer from multi-path propagation, that is multi-path coding. The receiver signal strength and the hidden terminal will be a problem. Next is satisfactory performance can be achieved through only long observation time. System is going to be simple. Advantage, but disadvantage we are going for three types: multi-path fading, next incorrect spectral utilization, and we are going to satisfy performance by taking longer observation. Next, cooperative sensing. Control channel are used to share the spectrum sensing result. It's going to control channel are used to share the spectrum. Next, CS, that is nothing but cooperative sensing, otherwise called as receiver detection technique. Previous one non-cooperative is going to be a transmitter. CS, cooperative is nothing but receiver detection technique, which gives solution to following problem: noise uncertainty, fading, shadowing. So for this one, the cooperative sensing will give a better solution. Next, this cooperative sensing types are centralized, distributive, and then external. Advantage is going to reduce the false alarm. Next, hidden node problem is sufficiently reduced. Signal strength is more accurate and increase in ability. Once we are going to talk about disadvantage: control channel, system synchronization, suitable for a geographical spread of cooperative node. The increased number of terminal leads to an increase in error. So these are the disadvantages of cooperative. Interference band. In this method, the secondary storage is allowed only if it does not degrade the primary user quality of service below the tolerance limit. So interference means in this method the secondary storage is allowed only if it does not degrade the primary user in what aspect is quality of service. That too, it should not fall below the tolerance level. Each primary user has interference temperature limit that can define tolerance to guarantee the certain quality. So each and everything is going to be a temperature limit. It should not fall below the temperature limit. Then it will be resulted in non-quality of service. That is, it will not give the better quality. Next, cognitive radio will measure the interference environment and adjust their transmission such that the interference to primary user is not above the regulator. The third point is to measure the interference environment. What was the interference which is going to happen in various environments? It will measure and then it will adjust the transmission such that the interference to primary user is not unaffected. Advantage: fully productive. Disadvantage: to measure the interface temperature at primary, which is in where primary receiver, it is going to be unusable once we are going for interference temperature. Next, narrowband sensing. Narrowband sensing, here we are going for energy reduction, cyclostep reduction, acid filter, covariance based detection, and machine learning based detection. Fourth sensing technique, covariance based detection. No prior knowledge of the primary user signal and noise is required. Blind detection. Disadvantage: computational and complexity based measurement. Machine learning based spectrum sensing. Machine learning can detect if trained correctly, can be result in good approach. Minimize the delay of the detection. Use complex model in an easy manner. Disadvantage: complex technique has to be adapted in learning, fast changing environment, and future selection affects the detection rate and add complexity. Large high data set has to be built. So this will be a disadvantage. Wide band sensing. So it's going to be a Nyquist band wide band sensing, then compressed wide band sensing. In Nyquist, here we are going for wavelength, multi-band, then filtered band. In compressive, non-blind, and blind. Next, wide band. So broadband communication system requires high data rate, therefore it results in high bandwidth. Thus, the secondary user need to sense wide frequency range of the radio spectrum to find the best available channel. So this is nothing but wide band. How you are going to approach the wide band spectrum? Divide the spectrum into several narrow bands and performance sensing sequentially a process that increases sensing time. Instead of going with a wide band, here we are going to divide into several narrow bands, so easily we can able to sense and then easily we can able to increase the time. Sense the narrow band in parallel by using multiple sensor and the performance joint detection. This approach results in high hardware cost and the fact that sensor synchronization. Compressive sensing technique to reduce the number of samples and reduce the noise. So that is compressive RF sensing. Next, the AIC. Reduce the number of measured compared to Nyquist one. Disadvantage: number of measured to be and used is not specified. Next, Nyquist based sensing technique. Disadvantage: reduced performance compared to the non-Nyquist. Last, comprehensive sensing with recording. Discrete cosine transformation is more accurate than the discrete Fourier transform. Reduce the processing time. So this will be a two advantage. Disadvantage: high complexity, reduce the performance, and the estimation of a specific level is needed. So that's all about today's video lecture. We will discuss with a new topic in